Hi, we are Group 1 from Section 6 and we will do presentation for our group assignment. My name is M.Rifqi binti Abdul Talib. My matrix number DE200082 and I will start the presentation first. So in the picture shown is one of the examples how power are distributed to the industrial. As we know, local utility can supply electricity to industrial facilities depending on the size of the load. Heat, cooling, lighting, and motor driven are some examples of the industrial application. Usually, the range of voltage supply are 11 kV, 33 kV, 66 kV, or 132 kV. In industrial power distributed, step-down transformer used to step down high voltage to low voltage and step-up transformer opposite operation of step-down transformer. Efficiency and simplicity are the main factors in the platforms of distribution transformer. Distribution transformers are designed to run at maximum efficiency between 60 and 70% of loads, which helps reduce the core loss. Next is technical problem that usually found in industrial power distributed. For example, overhead line set, underground cable trimming, circuit breaker failure, and transformer failure and overloading. For example, transformer may overheat and malfunction which result in power outage. Other transformer needs to fill in when one transformer fails. The problem is, transformer might not have enough spare capacity. Other than that, overloading working transformer might cause equipment lifespan to be cut shorter. Okay, next is the project requirement in this assignment. In this project, we need to design based on the loads given and also with additional 2 divisions with the load increment of 16% compared with existing loads. The existing loads are shown as in the table. So as we can see, in the table given, the existing load have 3 divisions. And another design that we need to create is with additional 2 divisions with the load increment of 16% compared with existing loads in the table. To design the single line diagram of the loads, we can use ETAP software or AutoCAD software to show the one line diagram. In this case, we use AutoCAD software to generate one line diagram. That's all from me. Thank you.
Hi, my name is Haniza Sharabi Tarman. I will present about the objective. So there are several objectives of this project. So the first one is to study the maximum demand of the industry. The second one is to determine the load estimation, transformer and cable sizing. The third one is to perform the calculation by using the Microsoft Excel. And the last one is to propose a new design of the industrial network.
My name is Muhammad Amirul Hakimi bin Zarawi and my meter number is DE200121. So now I will present about methodology, which is 1.0 overview of project planning. As you can see, the diagram shows flowchart on how we working on this task, and the flowchart is shown from how to calculate transformer sizing to cable sizing. So from the start, we study the task given and then suggest the transformer for each division, which is distribution transformer T2, T3, and T4. After that, we define KU, KS2, KS3, and KS4. After that, we check is the total loading is over than 10,000 kVA, which is if no, we should check again from the suggest transformer for each division. And next, if the total loading over than 10,000 kVA, the transformer sizing is calculated. And next is the cable sizing is calculated. After we get the transformer sizing and the cable sizing, the final transformer rating is selected. And then is the transformer sizing is suitable. If it's not, we should calculate again from the transformer sizing. And then if the transformer sizing is suitable, and then the transformer can be selected. The transformer sizing must consist of three criteria, which is the first one is total maximum demand, and the second criteria is voltage drop, and which is size transformer rating can be selected if the load is added for the third criteria. And this is the table for transformer sizing, which is first one is industrial load for each division, and then we should check for the criteria 1. After that, we should check for the criteria 2, and then next criteria 3 and n. For the methodology 2.0 is transformer sizing, which is for the first one is criteria 1, the value of utilization factor, which is Ku, and diversity factor, which is Ks, need to be considered. And then find the maximum demand for the division. Check if the division have bigger than 100 kVA rating. And then transformer rating should have bigger than total kVA system. As you can see here, this is the flowchart or workflow for the criteria 1, which is from the start. And next is estimate full load size of division. After that, we calculate the maximum demand. And then we should check the division have over than 100 kVA rating. And if it's no, the maximum demand is calculated again. And then if it's yes, divide the final total kVA system with 0.65. After that, select the suitable transformer rating with system kVA. And then the selected standard transformer should be over than total kVA system. And if it's not, the transformer is selected again with system kVA. And if it's yes, the transformer can be used. For the criteria 2 is the process to find the voltage drop from the load. It should be less than 10%, and then the voltage drop is evaluated based on the ratio of load kVA with secondary transformer kVA. So here this is the workflow for criteria 2 process, which is from the start. Choose the transformer based on transformer rating to be selected, and then refer the load from the list given, select the biggest load from the table list. After that, we calculate the percentage of voltage drop, and then the voltage drop is less than 10%. If it's no, the transformer must be selected again, and if it's yes, it will be n. And for the criteria 3, this is process to evaluate suitable transformer sizing after addition load and also after adding two divisions. New total maximum demand is calculated. The additional load is added, which is 60%. As we can see, the first chart for criteria 3 is from the start, we calculate total maximum demand and then multiple additional 60% of the load. And next is add two division and then calculate size of transformer rating. After that, select suitable size of transformer rating and n. For the methodology 3.0, which is cable sizing, flowchart of cable sizing is to determine what size cable can be used in industrial system. The value of current carrying capacity should be over than current load in order to the cable can be worked properly without being damaged. As you can see, the flowchart here, this is for cable sizing. From the start, check the current load and then select transformer given. After that, select type of cable that need to be used. After that, we calculate the cross-sectional area and then find current carrying capacity. After that, is the value current carrying capacity over than current load? If no, we should select the transformer again, and if it's yes, the cable is selected.
Hello, my name is Muhammad Nazmi bin Ahmad Kamal, DE200132. I will continue by present the next part of the project, which is design the distribution transformer. So based on the given list of industrial loads, I have come up with the Excel files. So here is the tables that we have insert all the value of the KU, SKU and SDB, and also the load itself with the apparent power for each loads. And after we have multiplied with the value, and we have the final answer of 3015.395 kVA for the apparent power demand of the system. And then to find the suitable transformer rating, we have divided with the 0.65, and we will have this answer with this value, and the nearest value of such rating for the transformer is 6300. Then for the voltage drop calculation, firstly we have a transformer and motor details, which is transformer size is 4000 kVA and secondary voltage is 11 kV and the impedance is 5% and allowable voltage drop is 10%. And the motor size, the biggest motor size that consume power is 1500 horsepower, 1119 kilowatt with power factor of 0.92 and 93% of efficiency. So based on the values that we have calculated some of the values, which is motor inrush kVA starting is 3720 kVA and the full load current is 2009.95 and 4199 short circuit secondary transformer, and maximum kVA of short circuit is 80 megaVAR, and the percentage that we have obtained is 0.23%, which is below than 10%. So here is the details of the transformer that we have chosen for the transformer 1 until transformer 6. So there is two types of construction type that we have used, which is oil fill and dry type. So here is the table that we have been referred for the selection of the details of the transformer. So next for the data for the cable size selections. So based on the feeder load demand kVA for the T2 until T6, we have calculated the cable size by using the information of data for the impedance for every transformer and also the K or the data by each cable that we have chosen, and the ampacity and the size cable that we have chosen, that we selected by having the area of the cable that we required for every transformer. So by using the formula, be using the I load, and we have the I rated and I short circuit, the area of the cable can be obtained. However, one of the issue is the cable size that we used have a carrying capacity of current that below than the I load that we required by the load. So we have one solution that to use or suggest new size cable that bigger than the calculated size by using the formula, which is, for example, for the T3, T5 and T6, we have an extra size cable and having a bigger ampacity value, and then we will have a bigger current carrying capacity for T3, T5 and T6, which is bigger than the iLoad itself. So this makes the cable is suitable for the system. And then as a result, we have designed the system or the distribution transformer for the T1 that using a 6300 kVA, T2 4000 kVA size transformer, and T3 500 kVA, T4 4000 kVA, T5 4000 kVA, and T6 is 500 kVA.
Hello, my name is M.Rifqi bin Azizan. My metric number is DE20015. So in this part, I will explain about the new outcome design. Firstly, for the new estimation load demand. This is the new load estimation demand, which is some additional feeder at E and F, and we declare as load 1 and load 2. And each one have 1005.12 kilovolt of apparent power, and the total from this is about 2010.24 kilovolt. And all of this we will get the result based on the previous apparent power times by 60% of increment according to the instruction. Next, we can see the new one line diagram. We can see it is quite different with the previous one, which is there are two another or extra feeders that we add according to the requirement, which is at T7 and T8. And it has a transformer that will connect with the load 1, and T8 also have transformer that connect with load 2. Okay, we can continue with the new size of transformer for the transformer 7 and transformer 8. We can see there are two tables that talk about the details of transformer. Moreover, we can see that the rating of transformer, the size is same with 7 and 8, which is 4000 kVA, and the primary voltage is 33 kilovolt, secondary voltage is 11 kilovolt, and the construction type is oil field with the impedance of 5%. Alright, let's continue with the cable sizing for T7 and T8. At the first table, at T7 and T8, the secondary voltage that we use is 11 kV, with the transformer rating is 4000 kVA rate, with the impedance of 0.05, and T, which is the duration of short circuit in seconds, 0.16, and the value of K, which is the short circuit rise constant temperature, which is 94, and the value of K, which is the ampacity duration factor, 1.105, and the size cable that approximately we get is 25 millimeter square, and the ampacity current is 98 ampere. At the second table, we can see the I load that we have already calculated is 52.75 ampere, and the rated current at the transformer is 209.95 ampere, and the short circuit current is 4198 ampere, with the cross sectional area is 17.87 millimeter square, and the new suggestion cable size that we use is 25 millimeter square, and that we can produce the current carrying capacity is 108 and 108.29 ampere. So we can conclude that the value of ICC is more than I load. So this cable is suitable to use at T7 and T8. Next, I will explain about the environment and sustainability. As we all know, electrical energy is very important thing in our daily life. High demand of electricity make the power generation to produce more energy every day. Therefore, it will produce some negative impact due to the increasing of global warming and greenhouse effect gases. All of this can affect the economic and living things such as animals, plants, and humans. So, the rate of pollution is become danger from day to day. To overcome all of the problems from not being worse, there is one solution that we can use which is by using renewable energy to produce electricity. The renewable energy that's suitable to use in Malaysia are solar, hydro, wind, and biomass. As a result, our country will be safe from any pollution and be able to live in a healthy lifestyle.
Okay, while we're doing this project, we found several weakness of this design. So the first one is required a high cost because it use the extra size of cable to ensure the carrying capacity is suitable with the current and it is needed by load. So next, it use a variety type of transformer. It use the dry and all type transformer with a different ampere power, which is 500 kVA for the smaller load and 4000 kVA for the biggest load. Okay, so as we know, the oil type transformer require the high maintenance because there are a lot of maintenance, a lot of testing that to be done to give the good performance. So for the dry tech, we know that it's less maintenance because it's naturally cooling by air, but it's required a high cost to use it in the industry. So that's all the pros and cons for this design, and hoping that is more improvement to be done in future. So, as a conclusion, the student gain the knowledge to develop the user-friendly tools by using Microsoft Excel to do the proper estimation in the industrial power system. Next, the student gain the knowledge to design and analyze a more sustainable network for the industrial loading. So the last one is the student have more understanding of using Microsoft Excel, transient analyzer program, ETAP, and AutoCAD software to design the one line diagram. So it's proven that our objective are fully achieved.